So we are in class today and we are working on this problem here, which is a rectangular board 12 inches by 16 inches. And so what that means is I have this rectangle, and in this rectangle I've got it 12 by 16, and I've got this unknown border. And again, if you didn't read that, you can go back and reread what the question prompt was. But it says I have a uniform border. Uniform means it's the same width all the way around, and we decided to call that R. You can call it whatever variable you want, but that's what we don't know. So if I know that that's R, there's a couple ways I can approach this problem. But if I take this, I can go this length here is R, this length down here is R, so my grand total for that width is 12 plus 2R. Some people might ask, can I write 2R plus 12? And the answer is yes, you can do it either way that you want. Oftentimes we see a binomial. That's a binomial because there's two things, binomials, two things. We oftentimes put the variable first. If that makes you feel better about yourself, then go for it. I honestly don't care how you feel. This is math. So then what we're going to do is we're going to calculate area because we were told that the area of the shaded region, or of the border, this area here, is 128 square inches. And we know just by looking at the rectangle that this inside rectangle is 192 square inches because it's 12 by 16. So 192 and a grand total area of 320 inches squared. So what I'm going to do then is set up an equation where it's going to be length, so area for a rectangle, again, length times width. So my area is going to be the length was 16 plus 2R. The width was 12 plus 2R. And that equals a grand total area of 320. To solve, I'm going to FOIL. So this would be then 16 times 12, 192. That's the first, right, 16 times 12. And then I'll have plus 32R plus 24R plus 4R squared. 2R times 2R is equal to 320. I like to rewrite it so that it's in descending order. So my highest power is in the front. Plus 56R plus 192 equals 320. And when solving quadratics, I want it set equal to 0. So I subtract 320 from both sides, leaving me with 4R squared plus 56R minus 128. This equals 0. I forgot there you go, 56R. Then I go through my process. Look for greatest common factor. They all are divisible by 4. I'm left with 4 equals R squared plus 14R minus 32 equals 0. I'm hoping, upon all hopes, that I can find two numbers that multiply to negative 32 and add to 14. On the side, I'm always thinking what multiplies to 32. I've got 8 and 4, but it's negative 32, so one of them has to be negative. To that. Those two obviously don't add to 14. I have 16 and 2. They multiply to 32, which is good because I'm almost there. It has to be a negative 32 multiplying, so one of those two numbers has to be negative. So one of them is plus and the other one is minus. I want the plus one to be the bigger number because I want this number to be positive. So this number here is 16. The other one is 2. I still have my 4 out in front, equals 0. And then I'm saying to myself, self, what makes this 0? Nothing. There's nothing I could ever put in there because there's no variable, so the 4 just stays 4. What makes this 0? R equals negative 16. What makes this 0? R equals 2. So the question then is, what is the width of the border? We have two answers, and only one of them makes sense because in context of a real-life scenario, you cannot have a width that's negative 16. I would challenge you to show me a measurement that goes inside of 0 to become a negative width. You can't have it. So while there are two answers, this is the only one that works. The width of my border is 2. This has a special name. It's called extraneous. Extraneous. Extraneous, bad. Extra bad, doesn't work. We don't need it in our question. And now for a question related to the review packet page that I sent out, the third question down referenced Samantha. And Samantha has a rectangular garden, so it's similar to this idea, where it says the length is x and the width is x minus 3, and she has a total area of 72 square meters. All right, so how do we find, again, area of a rectangle, length times width, so it'll be x times x minus 3. And remember that x minus 3 is the whole thing, so throwing that in parentheses. So the length times the width will equal 72. Out of habit, I like to distribute x squared minus 3x equals 72. And now it's like the problem that we did before. In order to solve, I need to have my equation, or it's easiest to solve if I have my equation equal to 0. So I will subtract 72 from both sides. X squared minus 3x minus 72 equals 0. And then I'm thinking negative 72, what numbers multiply to negative 72? 2 and 36, one of them has to be negative, but that's not going to get me anywhere close to the sum. The sum of the two answers has to be negative 3. So I'm thinking through other numbers that multiply to 72, having a firm grasp of your multiplication tables of 12, you'd remember that, let's see, 9 times 8 is 72, but there, again, one would have to be negative, and since my middle number is negative, I want the larger of the two to be negative. All right. Unfortunately, that doesn't give me a difference of 3. It gives me a difference of negative 1. So what else do I have? All right, so another example of a pair that multiplies to negative 72 is negative 12 and 6, but those add to negative 6, not negative 3. And I'm thinking through here, so if I go up from negative 9 to negative 10, 10 does not divide into 72 evenly. 11 does not divide into 72 evenly. So I actually do not have a pair of numbers that divide equally into that. So then I'm going to go to the ever famous and always hated quadratic formula. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do not expect you to have that memorized. I'll have that on the board, or it'll be on a worksheet or somewhere on the test, so that you don't have to use it from memory. These are the kind of things that you can find from a Google search pretty easily. Problem solving goes on in your brain. Memorizing formula is not always the case. So what does that mean? When I look at my original equation over there, a is equal to the coefficient of the first or the highest powered term. The highest powered term is x squared, so its coefficient is 1. B is equal to the next highest powered coefficient, which is the negative 3x. All right, highest powered, x is to the 1 power. It's the second highest power. Its coefficient is negative 3, so B is negative 3. And then C is equal to the constant, which is negative 72. And then I go to my equation, and I plug them in. X equals, I take the B term, which is negative 3, and I make it negative, so it's now positive 3, plus or minus the square root of B squared. Well, the B again is negative 3, so B squared is 9, minus, and here I'm not going to do, I'll just write it in, 4 times A is 1, times C is negative 72, and it's all over 2 times A is 1, so it's just over 2. X equals 3 plus or minus the square root of 9 minus, it's minus a negative, so that'll be plus 288 all over 2. So then this will be x equals 3 plus or minus the square root of 297 all over 2. And 297 is not a squared value. So it's not like there's going to be a square root of that. At this point, it becomes a calculator task. So to do this, I would actually split it up and do 2 different answers, because there will be 2 different answers. I would do 3 plus the square root of 297 all over 2, and down here I do 3 minus the square root of 297 all over 2, And just follow, and again, if you get to this place and you make a mistake in your calculator and you give an answer that doesn't jive with what you did for work, this still gets you essentially correct, and full, which is equivalent to full credit on a question. I mean, honestly, if you had all this work down, you understand that this is where I'm going to go, and you misapply this, you could probably still get yourself to full credit on that as well, because you're getting the major ideas. So again, the rubric that I used, 4 is essentially correct, which is an A. 3 is mostly correct, which is a B. 2 is partially correct, that's a C. 1 is minimally correct, that's a D. 0 is if you totally do a completely wrong mathematical concept or you leave it blank. Okay. Doing the exponents, properties of exponents, the first one that was on that little review sheet. There was nothing outside of the parentheses that were originally drawn, so I didn't put them on there because they don't need to be there per se. So then I'm only multiplying and only dividing, which means I can straight up use all the properties of exponents. And the properties of exponents are, when I'm multiplying same bases, I add exponents. When I'm dividing same bases, I subtract exponents. I look in the numerator. This is a base 2, that's a base x, that's a base 3. They cannot be combined with each other. In the denominator, I've got a 2, an x, and a 3, all different bases. They cannot be combined. However, top to bottom, I see that I have 2 to the third and 2 to the fifth. I'm dividing. So if I just think about those two, it would be 2 to the 3 minus 5, which is 2 to the negative 2. And then if I only look at the x's, I have x to the third in the top, so I'm going to subtract what's in the denominator to the minus 2. X to the third minus, because I'm dividing, negative 2. So that would be x to the fifth. And then I have 3 and 3 to the 2 in the numerator minus 4, because I subtract in the denominator, I subtract that out, which is 3 to the minus 2. So then if I take this and just think about a fraction, say, well, which one's in the numerator? Positives are in the numerator. X to the fifth is in the numerator. The negative 2 means it goes in the denominator, so it's 2 squared. And then the 3 has a negative, so it'll be 3 squared. I don't know why I keep hitting that. There we go. And that'd be the final answer. I could do it straight from up here if I wanted to as well. And to do that, I would just go properties of exponents. I have more 2's in the denominator. How many more 2's? 2, so it's 2 squared. Because what I'm thinking is, to the left, 2 times 2 times 2, in the bottom, 2 times 2 times 2 times 2 times 2, ran out of room. 1, 2, 3 of them reduced, I'm left with 2 squared. I'd have x to the third, and then this x squared, the negative means I need to put it on the other side, so it'd be x squared. And then I would have the 3 squared here again, because it's the same idea as I did with the 2 squared. That simplifies as x to the fifth, because same basis and multiply. 2 squared, 4 times 9, so x to the fifth over 36. Since most people do, I'm recording now by the way, since most people do the 2 equations method or process of elimination, we'll do that. So what I'm going to do is I look at those 3 and look to see, are there any variables that look like they're going to be easy to eliminate right away? This is a 5, that's a 2, that's a 1. So that'd be working with 2's and 5's and eventually having 10's. This is 4's and 3's and 2's, so probably ending up with 12's or something like that. Here, though, I like the fact that this is a 1, so I can take this equation, multiply it by anything I want to eliminate the x's in the other 2. So if I take that first equation at the very top up there, the 3x plus 2y minus z equals 7, and if I take the third equation and multiply it by negative 3, so I'm going to take this equation times negative 3 will give me negative 3x minus 12y plus 15z equals 12. Add those 2 equations, and always be checking that I'm multiplying and dividing here as I do this, but that adds to 0. I have negative 10y plus 14z equals 19. Now if I take the second equation, 2x minus 3y plus 2z equals 1, and if I take this first equation, or the third equation again, and multiply it by -2, I'll get negative 2x minus 8y plus 10z equals positive 8. Add those two equations. That first one adds to 0. I have negative 11y plus 12z equals 9. And now I have two equations with y and z. Negative 10y plus 14z equals 19. Not really fun and interesting to do here because those are some hard numbers to go with. But in that process, I would have to say, okay, well, what do I have to do to one equation or another equation or maybe both equations so I can get rid of a variable? If I multiply the top one by negative 10 and the bottom one by positive 11, the top equation would yield 110y minus 120z equals negative 90. The bottom equation would be negative 110y plus 154z. Someone should check my multiplication on that one. Plus equals 209. My y's add to 0. I have 120, which is negative, plus 154 is 34z. And I have 209 minus 90, or negative 90 plus 209 is 119. Divided by 34 is equal to 3.5. Take that, put it into that equation, solve it for y, then take those two numbers, probably put it into this equation at the end to solve for x, and that's how you can find all the x, y, and z to solve those equations. I'm not going to cover every question in the review, but another one I'll cover here is getting two variables and solving a system of linear equations. The one that starts with Amanda is planning a school fundraiser, selling two types of products, t-shirts and water. So we'll call T the t-shirts, W the water bottles. And we know that she wants to sell at least 100 items. So T plus W must be at least 100. And then I have, she wants to make a profit of $300. So that means $10 per t-shirt plus $5 per water bottle. Needs to be over $300. She wants to make 300. It doesn't say 300 or more or over 300, something along those lines. So then what I need to do is solve the system of linear equations. A couple different ways I can go. I'm going to go T plus, I'm going to subtract W from both sides. So I'll have T is greater than or equal to 100 minus W. I'm going to put that in the other equation for T. So where the T is, I'm going to replace it with 100 minus W plus 5W greater than 300. That would be 1,000 minus 10W plus 5W greater than 300. I'm going to move the 1,000 to the other side, subtract it from both sides. I would then have on the left side combine the W, so it's minus 5W greater than negative 700. Divide both sides by negative 5. And when you divide or multiply by negatives, the sign changes, and that would be 140. So it needs to sell water bottles less than 140. If I go back to the other equation, and I have T greater than or equal to 100 minus the 140. So T must be greater than or equal to negative 40. And then because I got a negative number, it makes me wonder if I did something wrong in my equations. But in terms of just strategically speaking, this is how you would go about solving these two sets of equations with two variables in there for water bottles and t-shirts. If you notice where I made my mistake, procedurally, it's all going to make sense here, and I followed the right process. Much like I've said in class, I'll occasionally miss a subtraction, or I work too fast on something else, and then I get an answer that doesn't make sense. It makes me go back and see where my mistake was. So if there's a mistake, I hope you can find it. If there's not, then maybe this was just a poorly designed question on my part. And if you've been wondering, yes, I have two dogs, so occasionally they make noises in the background of whining to want go in and out. So that's okay. For creating equations of lines, if I have something that goes through 3, 4, and there is, and it's perpendicular to this line, 2x minus 3y equals 6. First thing I have to do is figure out what the slope is of this equation. Most of us would probably put that into slope-intercept form. So that means subtracting 2x from both sides. So I'd have negative 3y equals negative 2x plus 6. And then going to divide by negative 3 each item. So I'm left with y equals positive 2/3 x minus 2. So the slope of this equation is 2/3. And the question says I want to be perpendicular, which means negative reciprocal when I'm talking about slopes. So the slope of this line will be negative 3/2. So once again, if I take that slope negative, so I take this and make it negative, and the reciprocal means I flip it, that will be the slope of my new line. So now to work through this problem, I know that it goes through 3, 4, and the slope is negative 3/2. Many of us will do this as our process. Y equals m, negative 3/2, x plus b. I plug in the x and the y that I know from up here. So the y value is 4 equals negative 3/2 times 3 plus b, because the x was 3. And so this would be 4 equals, and 3 is the same as 3 over 1, negative 9/2 plus b. I add 9/2 to both sides, which is 4.5. But so add 9/2 to both sides. I would have 4 is the same as 8/2, and I'm adding 9/2, so I'm going to have 17/2 equals b. So the equation would be y equals negative 3/2 x plus 17/2. And I think it asked me to write the line in slope-intercept form, so I'm good with that one. And then we have John's t-shirts. The break even says, when does he break even? So break even is when income first equals his expenses. So we first have to look and say, well, what's his income, or how much is he selling these for? So he's selling these for $15 a t-shirt. So 15T is what he's selling them for. And then I need to find out when that is going to equal his total expense. And his total expense is $200 plus $5 per t-shirt. So 200 plus 5T. And so what's going on here, these are negative values because they're costs. All right, so if I add 5T to both sides, I get, but I'm doing it as when income equals, so we'll leave them both as positives. So I'm going to subtract 5T from both sides, subtract 5T, I'll get 10T equals 200. When T equals 20, that's when his break-even point is. It was actually a pretty easy problem to solve once you figure out how to set it up. So when does his income equal his costs? Because every time his number of t-shirts goes up by 1, this goes up by 5. All right, so at 21 t-shirts, this would be 200 plus 5 times 21, and this would be 15 times 21. At this point, this number here is going to exceed this number over here, meaning I'm actually making profit. Prior to that, prior to the 20 t-shirts, this side over here is going to be more because my costs are more than my income. So that's the John's t-shirt problem. All right, and then the last one I'll do here is just one more quadratic in factoring. 2x squared minus 5x minus 12 equals 0. Since we're already set equal to 0, I don't have to do anything there because that's where I should always start. Then I'm looking for, are there common factors that I can pull out of every term? 2, nope, can't do 2 because the middle term is not. So at this point, I have one of those problems that's going to be kind of a guess and check. So this will be 2x and this will be x. And some of you are kind of start thinking like the box method here. So 2x and x. I need numbers that are going to multiply to -6. So maybe I have a +6 and a -2 as my first guess. This would be, when I look at multiplying the square, it's 2x times x. So this square becomes 2x squared. The next one over there is going to be 6 times x, so that's 6x. This one here is 2x times -2, that's -4x. And then the last one is 6 times, that's -12. So these two are good, but these two are not because those add up to +2x. I need to be -5x. So then you would try a new one. And I need that middle number to be negative. Let me just get rid of this one here too. All right, and so looking at things like 4 and 3, they multiply to 12. This will give me 8x, this will give me 3x, and the difference is 5. I want it to be negative, so this is the negative because it'll be the bigger value, making this the -8x. This will still be -12, and now I have middle terms, -8x, +3x, they add to -5x. So I would factor into 2x plus 3 and x minus 4 equals 0. This is supposed to be a 4. All right. And then to solve, I'm wondering, okay, when is 2x plus 3 equal 0? When does x minus 4 equal 0? Well, down here, this bottom one, when x equals 4, I just added 4 to both sides. When x equals 4, or when I plug 4 in here, 4 minus 4 is 0, that equals 0. So this is one solution. Here's the other one that takes a little bit of work. Subtract 3 from both sides. 2x equals -3. Divide 2. X equals -3/2. Two answers to that. And as I said in other times, and again, I'll say now, these are the two places where if I graph this parabola, it's a quadratic parabola, it will cross the x-axis. So here's my x-axis at +4, 1, 2, 3, 4, dot right there. And at -3/2, well, -3/2 is halfway between -1 and -2. It'll cross right there, and it'll be something like this when I would graph that as a parabola. That'll do it for this covering of the review questions. Again, like I said, I wasn't going to do all of them, but I did quite a few. When in doubt, reach out to some of your classmates. You can obviously put these equations into something online, possibly even to ChatGPT, see if it'll give you a solution that makes sense anyway. Sometimes ChatGPT does not. And that'll do it. We'll see you on Thursday for the exam.